Well, good morning and welcome to today's first ever of the 2021 season for the Drought Hour webinar series. I have the privilege of introducing today our speakers. Our first one will be Dr. Adam Varenhorst, and he's going to talk about, do seed treatments provide a benefit when it's dry? Adam is our extension field crops entomologist, and he has done great work within the last 5 years of being with SDSU Extension. So with that, I will turn it over to Adam. And just wanted to remind any of the participants that if you do have a question, you can go ahead and enter that in the Q&A feature at the bottom of the screen or in the chat, and we'll address them as they come up. So thank you.
All right. Well, good morning, everyone. It is a Monday, so you'll notice I don't have a webcam. I'm having some technology issues, but I'm still going to be able to give this presentation, and fortunately, I still have audio, so that's the little things in life, I guess. And today I'm going to be talking about seed treatments. Do they pay off? And I'll mention right now that I'll be talking about seed treatments in regards to soybeans. This is what I've done some research on, but I can touch a little bit about it on a few of our other crops as well. But for the most part, this talk's going to be pretty focused on soybeans. And so if we get started, and we think about some of our early season soybean pests, a lot of times I get questions about soybean aphids and seed treatments, and I'll touch on that. But really our big ones are bean leaf beetles, white grubs, seed corn maggots, wireworms, and to some extent, grape claspus beetle or just the claspus beetles, because those larvae will feed down in the soil. And so when we think of seed treatments, we're not just protecting the seed though, we're also protecting the foliage, because those neonicotinoid active ingredients actually will move into the plant. And so that's why in some instances we have the soybean aphids, bean leaf beetles can be reduced. I will say though, for the most part in South Dakota, our soybean aphid populations are normally not showing up really early in the year. If we look at the weather today, it's cool. We're a little cooler than some of the other states. And that can have a little bit of an impact on when those pests show up in the field. And so when I think about what we're really managing in soybean with our seed treatments, maybe a little bit of soybean aphids just in that tail end of when these products are still effective, but we're really trying to manage our bean leaf beetles and to some extent white grubs, seed corn maggots, wireworms, and if the field has a history, the claspus beetles. And so if we think about this, we have some shortfalls, because if you've recently looked into purchasing or already have purchased some seed treated soybeans or other seeds or are planning to, we don't have a lot of recommendations for the use. We don't have a lot of recommendations about when to use a seed treatment, whether it varies by planting date, plant populations. And so it's tough. We don't have those good recommendations. And one of the reasons why is it's very tedious to get out in the field and collect that data, because you have to look at what's going on both below and above ground when the seed treatments are active. And so a few years ago, I conducted some research, and we used the research farms here in the eastern part of the state, and we looked at seed treatments. When we also looked at planting dates and seeding rates, we were really trying to tease apart a lot of different things here. And so one of the first things we did was we made sure we used the right maturities, because in some historical studies, some of this work has looked at seed treatments. Maybe it didn't always use maturity rate, soybean for that were right for the areas. So we were trying to really make sure that we had this optimized project. And so here's what we did. At each of those 4 locations, we did an early, and this was done in 2016, 17, and then we had 1 year or a few locations in 18. I won't be showing those, but we planted in May, or I should have put a little note here, as early as we could possibly get out in the field. And then we always did it a month later. We went out for our second planting date. So typically that was sometime in June. We called that the late planting date. And then we used 7 seeding rates. For most of you on the call, when you see those bottom numbers, you're probably scratching your head and wondering if we were crazy. But we started at 60,000 seeds per acre and went up to 180,000. And we did that in 20,000 increments. So we had those 7 seeding rates. And the reason we went so low is there's actually quite a bit of research now that's looking at that 80 to 120 range, and seeing that there's a benefit to planting in that. You typically get the same yield, sometimes better. So we were curious, what does that look like? And then we had 3 seed treatments. We had the untreated control, our fungicide only, and then we had an insecticide plus fungicide. And so we had those on each of those seeding rates at all of the planting dates. So we were trying to really get a comprehensive data set here. And so I'll start with our 2016 data, and we'll start with the Northeast Farm. And first, we're going to look at stand counts. And so one of the things that we saw was this was a cone planter used for the first year of our research plots. And one of the things we noticed was sometimes you don't get the stands you want. And just to point out, at 180,000, we were jumping around quite a bit, but we did notice that, I don't have this highlighted, but at the early planting date at the Northeast Farm, without any treatments, we had about 125,000 seeds per acre when we put 180,000 in the ground. When we had the fungicide alone, we got 151,000 seeds per acre. So definitely an increase in our stands, and the fungicide plus insecticide, we really didn't see. It actually went down a little bit. We didn't see a lot of benefit to having that insecticide. When we looked at our later planting date, everything was pretty similar. And that wasn't just for the 180,000. It was kind of similar across the board for all of those different seeding rates. So for that location, it didn't look like the insecticide seed treatment really did a lot. And I won't take too much away from the fungicide part, as Emmanuel will be speaking later and might be covering some of this stuff. But it looks like across the board, there's maybe a little bit of benefit at 160, but so one off that we can't really say that that was doing much. So if we look at our Volga location, we actually didn't see as much of a benefit at our early planting date for that 180,000 seeds per acre treatment for stands. But again, it could have been the planter a little bit, so I won't spend too much time on the rest of these. But the biggest thing is that there's going to be a lot of variability. And probably the most important thing is to make sure you go out and do some tests with your planter. Make sure that you check the populations, know what you're set at, and check a couple times before you go out and plant in the field. That's probably the best advice I can give you for stands at this point in time, because they're pretty variable. And if your planter isn't putting out what you think it is, you're going to have some issues on top of that. But for stands overall, pretty variable, and we just never saw real consistent benefits of having that insecticide plus fungicide treatment. And then when we jump to the next year, I'll spend a little bit more time on this because we got a precision planter in 2017. And so the stands, we were actually able to put out in our tests, we were putting out the seeds that we were supposed to be. So what's interesting though is if we look at some of these treatments, we'll go down the list here. At 60,000, we still dropped a little bit, but with the fungicide insecticide, we were seeing a benefit at the Northeast Farm for our early location. We didn't see so much for the 80,000, not so much of a difference for 100 or 120. What we always notice is that we lose a little bit of seeds. Our stands never really match up. That's expected. It gets really daunting though, at least in our opinion, when we get up above that 120, the 140, 160, 180, you'll notice we really weren't getting close, at least at the Northeast Farm, to what we were expecting for our stands to match what our seeding rates were. And again, we saw a little bit of a benefit at 180 for that location and the early planting date to having a combination treatment. And so maybe there was a little bit of benefit that year in 2017. It's been a few years ago. I should have mentioned this at the beginning. 2016 at the Northeast Farm was actually pretty dry at our early planting date. The later planting date had some water, had a little bit of precipitation, so that could have affected it. In 2017, though, it was actually quite opposite. It was really cool, damp during our early planting date, and so maybe that had a little bit of an issue for our emergence. We did see some of those very characteristic lightning bolt soybeans. They just were having a hard time coming out of the ground. we jump to our later planting date, though, we don't see a lot of changes. So the stands were actually a little bit worse at the Northeast Farm. We jump to Volga, we see that we actually had a little bit better conditions. So it was a little bit warmer down in the Volga area compared to the Northeast Farm when we planted. But still, we don't see these huge benefits. We still also are seeing that we aren't getting all of our seeds out of the ground. And we see that at the Brookings location also. So the Brookings and Volga locations were only about 6.5, 7 miles apart. And at the Southeast Farm, we also noticed that we just weren't getting very many seeds out of the ground with the early. However, our later planting date, we actually did a lot better. So something else I can tell you for your stands, make sure that you have your planters calibrated, know what you're actually putting out for seeds. Another thing is make sure the conditions are really good. Because the conditions for our later planting at the Southeast Farm that year were much better than what the early were. The ground was still a little cool across all of the locations at the early planting date in 2017. And you can see that the stands did do a little bit better with our later planting date. But stands don't always translate directly into yield. So let's break out some yields. And if we look at the Northeast Farm, so that's our South Shore location for 2016. Remember I said the early planting date was pretty dry that year compared to our later planting date. So if we just look at the averages across the board, our later planting date actually yielded better than the early one. And that's because there just wasn't moisture available for those soybean early in the season. But if we look at, I put the averages down here, so that goes across all of the seeding rates. But if we look at our averages for those 3 treatments, we see that we didn't really, at the Northeast Farm when it was dry, see much of a benefit for a combination treatment. So an insecticide plus a fungicide didn't deliver much in terms of yield. We didn't see much of an improvement either when we looked at when we had a little bit of moisture. So everything yielded better, but we didn't really see much of a benefit there. Something else to point out, though, I highlighted it for you guys, is I said it was dry that year up at the early planting date at this location. And so if we look at our 60 to 100,000 seeds per acre, our 60 actually out yielded the 80 and 100. We didn't really see that. We saw a little bit of an improvement at the 60. But here's the thing that really catches us a lot is we actually saw that the lower seeding rates out yielded, and maybe because it was a little bit drier, those higher seeding rates. And there's been some research, I'm not the only one who's seen this, that soybean at higher seeding rates, there's actually some competition going on in your row. And so you're not going to get all of those soybeans out of the row. Even when you plant 180,000, if you go above that, you're probably seeing a little bit more of that competition. And if you have more questions on that, I'd invite you to contact Dr. John Kleinjohn here on campus. He's our agronomist, and he may be able to visit with you a little bit more about that. But from strictly the seeding rates, it looks like when it's drier, and it makes sense, lower seeding rates may be a little bit better. I'm not saying to go out and plant 60, because I will also point out to you all, when you plant 60,000 seeds per acre, you really get that itch to go replant because your stands look terrible because there just aren't very many seeds out there. But when they do come up, they do eventually canopy. We didn't really see much of a difference in weed pressure between the different plots. And so we did see some yield improvement though. But what I also wanted to point out was that we didn't really see for yield and improvement, even at these lower seeding rates or the higher ones, any benefit of having the seed treatment. And why might that be? Well, at the Northeast Farm, we didn't really have a lot of pest pressure. We didn't see those early season insect pests that we would be concerned about. Now let's jump to the Volga Farm. Again, if we look at our averages, we didn't really see much of a difference. And we're to that level of we didn't see a difference where when we talk about statistics, even though this was, maybe there's a little bit of variation. When you look, a lot of times our untreated populations actually did better, a little bit better than the combination treatment. So in these conditions, things wouldn't really warrant it. I will point out, look at these yields. When we do have moisture early in the season and the conditions are really favorable, planting soybeans early in South Dakota can really be a benefit. You can get some really nice yields. Uh, and same planter, same field, just a little bit month apart, we see that there were some major differences in yield between early and late planting. But we didn't see much in terms of anything else. Again, our lower seeding rates, even when we had favorable conditions, we didn't really see a huge difference in yield between the low and the higher seeding rates. And that's pretty much the same for early or late. So not that I'm saying anybody should go out and plant really low seeding rates, but something to consider. When we jump to the Brookings farm still in 2016, again, we didn't really see a benefit in 2016 for having that combination treatment. So it did cost more money to have a combination treatment on the beans, and we weren't seeing a yield improvement. Again, not a ton of differences. Down at our Brookings location, we did see a little bit of a difference though. Our higher seeding rates did yield a little bit better than our lower seeding rates. And so they weren't statistically different, but I know a lot of people will see a 4 bushel per acre difference, and sometimes that's enough to consider changing things. At our later planting date, we actually did see a little bit of a difference, but again, nothing really jumped out as far as the statistics go. And so let's jump now to the Southeast farm. So down by Beersford, still in 2016, and now we're seeing a little bit of a difference with our seed treatment. And if we look at the early, we saw a 1.6 bushel per acre increase for having the insecticide plus fungicide combination. This, I believe back when we did this, and I haven't checked, you'd have to check for the expenses for having a fungicide and insecticide. I believe this was $15 to $18 back in 2016 and 17 when we were calculating out whether or not it was beneficial. So, you have to really look at your bean prices and the price of your treatments to see. Most of the time, though, 1.6 bushels aren't going to really pay a lot of those bills. However, if we look at our later planting date, we see that we actually had a 4.1 bushel per acre increase. And so now we're getting into that realm of sometimes that can be profitable. So why did we see this at the Southeast farm? Well, one of the big things is bean leaf beetles. We typically have more bean leaf beetle pressure in the southeast part of the state. And some of that is due to the fact that bean leaf beetles don't overwinter the best in South Dakota. When we have extended periods where the air temperature is below 14 degrees Fahrenheit, bean leaf beetles start to have increased death in the winter. If we have snow cover, that can improve their chances a little bit, but at the Beersford farm, down at the Southeast farm, we typically see bean leaf beetles in the spring. And this was no exception. At this plots, we saw bean leaf beetle pressure, and it could account for what we were seeing here. So that above ground feeding actually can have some impact on yield. Now, we didn't measure that directly, but we did see that that treatment had a little bit of an impact. I will state, though, that if we look here, our fungicide was also improving conditions a little bit, but we still had about a 2.3 bushel per acre increase just in having that insecticide also. So it's not always consistent, though. And I also wanted to point out that for our early planting date, the lower seeding rates yielded pretty similar to our higher ones. When we got into our later one, we actually saw that the higher seeding rate out yielded our lowest seeding rate. And so one of the things with that is that there can be a lot of variation. These were small plots, so some of that has to be taken with a grain of salt. But if we are going into a drier year, my instinct would say to go, maybe don't go all the way down to 60, but move down a little bit on your seeding rate. Save some seed and maybe also improve your chances if there are dry conditions. And I'll talk more about that in a minute. So now let's jump to 2017. So for yield in 2017, we'll go to the Northeast farm first. We actually saw a 1.9 bushel per acre increase. Conditions were more favorable this year compared to the first year. We actually saw that the fungicide and insecticide, the average really outweighed just the fungicide alone. We can't say that we were seeing a lot of benefit, though, because the untreated alone didn't do too poorly. So compare that to our later planting date, we didn't really see any benefit of the treatments at all. And in 2017, when we had a better planter, we actually saw, and we knew we were dialed in a little better, we actually did see that our higher seeding rates did yield a little bit better on average than our lower seeding rates. And it looked like kind of the sweet spot for where we didn't see a ton of yield reduction was actually in that 140 to 100,000 seeds per acre range at the early planting date. When we jumped to our later planting date, we saw a big difference, excuse me, between the 180 and the 60, but we didn't see as much of a difference between 120 to the 180. So there were still a little bit of statistical differences, but not a ton. So we can't always say that the lower planting rates yield very comparatively, because sometimes they don't, but we also didn't have as much money in the ground due to those lower seeding rates. And so if we jump to Volga now in 2017, we had a little bit of an improvement, but there wasn't really a statistical difference. And again, for early or late for our treatments, as far as yield goes. And if we look at our seeding rates for yield, we saw that there was a little bit of a difference. So these letters over here indicate that the lowest seeding rate didn't do as well as the rest of them, but there weren't a ton of differences. And if we look at our later, we see that when we got to about 180 to 100, we didn't see a ton of differences either. Now, if we go to the Brookings farm, so again, this is just a few miles apart. The biggest difference is the soil types. So the Brookings and Volga do have different soil types between those two farms. And if we look at the Brookings, we saw a little bit of an improvement with the combination treatment compared to the untreated control. But we also saw that in both cases, the fungicide alone did a little better. So it's very tough to say across the board that seed treatments of fungicide, insecticide will improve conditions for you. If we look at those rates for the seeding rates again and the yield, we see again, with a little bit better planter, the early we saw some differences. However, our later planting dates at the Brookings farm, we didn't see much of a difference at all. If we go to the Southeast farm, again, we had bean leaf beetle pressure in 2017. And again, we saw some improvements in having a combination treatment. That insecticide seemed to pay off more. And so a 4.2 bushel per acre increase at our early planting date and 2.4 at the later one. And so if we look at our seeding rates, again, for the early, we did see a little bit of an improvement in yield with the higher seeding rates compared to the lower one, but the later we didn't see as much. Now, I grew up on a farm, and I was actually just visiting with my dad about this today because he's still farming. And there is a lot of belief that the higher seeding rate, if you have a little bit of compaction on the top of your soil, higher seeding rates improve the chances of those seeds breaking through. I know that those are some firm beliefs out there, and I've never been able, I'll say right now, I've never been able to convince him. He still plants at about 160,000 seeds per acre. So I've talked to him about this. And so if I can't convince my own dad, I want to throw that out. Maybe I won't be able to change your minds either. But, in looking at some of this, we do see some evidence that maybe if we cut our seeding rates back a little bit and we think about those stands, if you have a precision planter, maybe you're going to be dialed in a little bit better. You can trust what you're putting out. You should still check, but if you have an older planter, especially if you have a finger pickup planter, there's a chance that you might not be getting the exact stand counts out there that you'd be expecting. And maybe that's because you weren't putting as much seed out. I think, and sometimes the conditions just really affect how much stand we actually get. But when it comes down to yield, I mean, it's a little bit variable in our research, but I'm not the only one to look at this. There's been large studies. A lot of locations recommend somewhere in that 120 to somewhere in the 80,000 is kind of that optimal. 120 is normally where people suggest you start to kind of get used to seeing those reduced stands in the spring, but there can be a benefit to that. And so a higher population at the start of the season, a lot of times results in a lot of lost seed, and it doesn't always result in consistent increased yield. However, we saw some variation there, so take it with a grain of salt. There can be variation. And yield increases from seed treatments can occur, but they are going to be location dependent. You do need to have a history of a pest problem. If you are down in that southeast part of the state, maybe you have more risk because of the bean leaf beetle populations. We don't really see a lot of those other early season pests here in South Dakota. There's always a chance that you could have some wireworms out in the field depending on your rotation. I will say right now, though, that those seed treatments aren't killing wireworms. They deter them. So if you have a really large wireworm population, you're still going to have wireworms feeding on those seeds. The weather can also really affect what early season pests. After a really wet year, you can have more issues with some of those pests like seed corn maggots because you had more plant debris out in the field. The conditions just favored it. And so there's a lot of factors that can really influence whether or not seed treatments can be favorable, whether you'll see an improvement in yield from them. And so for South Dakota, the big takeaway message for you today is a lot of our early season above ground insect pressure, as well as Emmanuel will talk about diseases, probably have more of an impact on our yield due to seed treatments than weather conditions. So if it's wet, obviously you have a higher risk for some of those diseases. But as far as the insects go, dry conditions don't necessarily mean the seed treatments are going to give you a yield improvement and protection from insect pests, because we do need to have those insect pests present. And this is a recent article I put out, was a bean leaf beetle overwintering estimates. So every year I put this together, and you see those percentages, each location I went through. If I find my mouse, I go through and I calculate from January 1st on every date that we had that was below 14 degrees Fahrenheit for the low. And I mentioned that bean leaf beetles don't like it that cold. They actually can kill them. They overwinter as adults, so they're not quite as hardy as some of the other insect pests. If we look at our map, we accumulated enough cold days from Selby to Millbank. We probably saw most of those areas having about 100% mortality for bean leaf beetles. That's pretty consistent to what we see every year. It gets cold. The further north you go in South Dakota, it gets pretty cold. What's kind of a surprise this year is Highmore and Huron are normally also at 100%, and they weren't this year. Highmore was at about 80%, Huron's 96%. So if you're in between these areas, you could have bean leaf beetle pressure this year, and sometimes we don't see that. As we go south, what's interesting is we actually had a little bit colder winter down in the far southeast than we normally do. So these numbers actually went up a little bit, but still not 100%. So anywhere we don't see 100%, bean leaf beetles more than likely survive the winter. If we had snow cover, or you have plant debris, or if they had a good place to overwinter, that's going to increase those overwintering chances also. And so I don't have a crystal ball, but if I had to guess, we could see some bean leaf beetle pressure this year. Now, if it's also dry, I guess my recommendation would be, if you're kind of in this circle right here, insecticide seed treatment might be worth a consideration. If you're down in this area, you might really want to consider it, because you might see a benefit. Because one of the issues with bean leaf beetles is they are an early season defoliator. When our beans are first emerging, there isn't a lot of leaf tissue available. And so I've seen in the past, very large bean leaf beetle populations can just really hit bean fields really hard, and you can see stand reductions. If there's just not a lot around, if you're an early field, they will hit your field hard. So it's something to consider. So I'd like to take a second just to thank this guy right here. Actually, this is Brady Hospedale. He's a former student of mine. He conducted the field studies. It was for his master's degree. I also like to thank the South Dakota Soybean Research and Promotion Council. They funded this two-year project. And I'd also like to thank some other people from my lab that helped with this project, collecting the data. It was pretty time intensive, but it was very interesting. So here's some contact information for me if you'd like to give me a call. I will say I'm not always in my office. COVID's made it a little bit easier to work from home. And so I will be getting out in the field hopefully soon. This week and the rest of this week looks like it's going to be a little chilly, so not a lot of insect activity. You can also reach me by email. This is probably the easiest all summer long. If you shoot me an email and really need to talk, I'll just give you a call with my cell phone and then we can chat that way. But that's typically the easiest way to get a hold of me. And if you'd like to check out any of those articles I mentioned, you can look them up on the extension website. You can look my name up, or you can just type in bean leaf beetle for the mortality article to find that, or any other articles. So thanks a lot for your time.
Well, thank you, Adam, for your presentation. If there's questions, there'll be some time at the end for questions for Adam, but if you have something pressing, please go ahead and put it in that chat or in the Q&A and we can get that addressed a little earlier. The next presenter will be Dr. Emmanuel Byamukama. He is our state extension plant pathologist, and he's one that I work very closely with, and he's got some information on fungicide seed treatments, considerations under dry soil conditions. So with that, I'm going to go ahead and turn it over to you, Emmanuel. You are muted, Emmanuel.
All right, there we go. You able to hear me now?
Yes, thank you.
All right, sorry about that. Thanks everybody for joining us. And this morning, I would like us to discuss a little bit about fungicide seed treatments, especially considering the dry conditions. And I'll be referring a little bit to what my colleague just shared with you, Adam, on fungicide seed treatments. So as we know, we care about seedling pathogens that are going to affect roots or kill seedlings, all those pathogens that are going to cause the seed to rot and hence prevent germination. So just as a reminder, these pathogens that survive on the seed or in the soil are going to affect the seedling vigor. If they kill plants, definitely you'll have reduced plants by unit area. And also pathogens that survive on the seed can be moved, and that can be a source of inoculum. So if, for example, you're planting seed coming from Nebraska as an example, or from Mexico or Argentina, if that seed is carrying a pathogen, now you have introduced the seed in your the pathogen in your field. So as seed treatments can help us to address these issues, improve on the seedling vigor, improve on plant stand, and also control pathogen spread. So these pathogens are two types. There are those that survive on the seed and also those that survive in the soil. So seed treatments are going to help us with these two types of pathogens. So the seed-borne pathogens are going to cause issues with seed quality, also seed germination. I have here a few examples. A loose mud in wheat, instead of having sound seed, you're going to have just what would have been the place of seed filled with fungal spores. In the case of common burnt, this is also a disease that can survive on the seed, where you should have a seed is replaced by the spores. Then we have common smut in corn that you're all familiar with. So these are some of the examples of pathogens that are going to survive on the seed. And for the rest of the talk, I won't cover these, but I wanted to give you as an example. And whether we have wet conditions or dry conditions, these pathogens are not affected by the conditions in the field at the time of planting. So as Adam said, we'll use a lot of examples from soybean because that's where we see more root rot issues, more root pathogens that cause concerns. There are also seed-borne and root rot diseases in corn and wheat, but not to the extent that we see in soybean. So a few examples here of pathogens we'll see in soybean. We have here Rhizoctonia. And the way you know that you have rhizoc is to look at the way the roots or stems are kind of rotted, and there's a sinking in of the lesion around the roots and stems. For Phytophthora here on the right, you see the lesion that rises up above the soil line, and that color is maple brown, dark brown color that is going to be on the stem above the soil line. and that would tell you that you have Phytophthora root rot. When it comes to Pythium, this pathogen can be on many crops, on cereals, on soybean. The one characteristic of Pythium root rots is look at the clipback of roots that are infected. So you have extensive rotting and the clipping of the roots. That is typical of Pythium, especially where you have mushy rotting with some wetness to the rotting. That would be typical of Pythium root rots. Again, this pathogen is pretty widespread. It's going to be on pretty much any crop out there. Other examples of root pathogens that we're going to deal with. So sudden death syndrome, which is caused by Fusarium vulgariforme, is one disease that we see, especially these days. It seems to crop up more and more in South Dakota. It wasn't a major disease in a few years back, but yeah, Fusarium caused by Fusarium vulgariforme in soybean can cause sudden death syndrome. We have several species of Fusarium that can infect corn and cause issues. One way to know that we have Fusarium root rot is to look at the extensive rotting of the crown area. You may also see it in the roots, but when you split that stalk and you see this discoloration going to the inner parts of the stem, that would be a characteristic of Fusarium root rots. So what are some of the risk factors we consider for root rot problems? Adam mentioned the factor of soil temperatures at the time of planting. This is a huge factor for a number of diseases, especially Pythium and Fusariums. Those tend to be more active in low temperatures. Soil moisture is a big factor, especially for those water mold pathogens, like Pythium and Phytophthora, but also other pathogens like Fusarium that causes SDS is going to be more effective at low temperature, at higher soil moisture. Also, the field history is a big risk factor. If you've had Phytophthora, it's probable that you'll see it again because some of these diseases have structures that will survive for a long time in soil. And of course, your host, the susceptible host, will be a risk factor. If you're planting a susceptible variety, say for soybean cyst nematode or Phytophthora, you're not gonna, the level of disease you'll see will depend on the susceptibility of that variety. So now looking at the planting conditions, especially now that we know large parts of the state are having low soil moisture, could there be a difference in terms of pathogens that we might see affecting our crops? So we know Pythium, which is a water mold pathogen, is one disease that could be limited by moisture content in the soil. Phytophthora is another one. So these two pathogens are the water mold pathogens. They are fungal-like, but not necessarily fungal. They're called omycetes, and these tend to be promoted by high moisture. And one of the reasons is that they produce motile spores, or they're also called zoospores, that require a film of water or free moisture between soil particles, and then they will swim to the root soon after the plant roots start developing. I will make a distinction though, and I'll talk more about Phytophthora, that Phytophthora can affect the crops throughout the season. And so that's one disease we may want to discuss a little bit more. I didn't mention about Fusarium vulgariforme, which is the pathogen that causes sudden death syndrome. This Fusarium species actually is promoted by higher soil moisture. And so if we have seedlings emerging when the soil is pretty well drained, when there's not an excessive moisture, we could see reduced disease pressure from this disease. So I have to make a distinction here that as long as we have moisture in the soil that can promote germination of the seed, you still have pathogens that can infect the root via hyphae growth of the pathogen. So it may not necessarily be the motile spores that are swimming in that free moisture in the soil, but the pathogens within the root zone where they can encroach on the root via production of hyphae, then you can still have infection caused by these pathogens. So as long as we have some moisture in the soil, that will encourage germination of the seed. Granted, you have very low level of disease infection, so you won't have as much of a severity as where you have, say, for example, flooding conditions, but we still have disease pressure within the nearby area around the root where the pathogen might be in touch or in contact with the growing root. Excuse me. So we should not let our guard down just because we may have low soil moisture and not do anything about the problems we have in the field because again, we can still have some infection, although the risk or the level of severity is going to be low for these particular pathogens. So how about those pathogens that are going to be infecting the crop throughout the season, whether we're a bit dry at the planting time, what should happen? So those are a few that we're going to review. And the first one is soybean cyst nematode. I believe most of you have heard something about the soybean cyst nematode, but it's the #1 yield reducing pathogen for soybean. And you can see here in the part of the field where we found SCN, how the plants look stunted. You know, the rows are not filled in, as you can see in these other parts of the field. And if you have not seen SCN, this is how it looks on the roots. Pretty small. These kind of creamish yellow cysts on the roots. These are females. You know, they are filled with eggs, as I showed here in this picture. So one cyst can carry up to 300 eggs per cyst. So they can be pretty prolific in the field. And one of the challenges of managing SCN is that you usually don't see above ground symptoms. So soybeans can look just fine, but actually the roots could be loaded with SCN and then you could be losing yield. They can survive in the soil for a long time without the host, up to 10 years in fact. And as I mentioned, one cyst can have up to 300 eggs. And this cysts can go through a life cycle 3 times in one season. So between 24 to 30 days, depending on the soil temperatures. And so you can have a quick buildup of the soybean cyst nematode in the soil, especially under drier conditions. The life cycle of the soybean cyst nematode tends to be reduced. And so you can have a quick buildup of this SCN. So I'd like to spend a few times just to talk about the life cycle of the SCN. And the infecting stage is called the juvenile stage, and that's the worm-like stage of the nematode, and it will swim in the soil where you have a free moisture or some stream of moisture between soil particles. And so where you have some excessive moisture in the soil, you can have a higher infection rate of the nematodes. But like I mentioned, any conditions that will, any moisture levels that will encourage seed germination will also promote infection of the either the nematode or the pathogen, where the juvenile or the pathogen propagule is close to the roots. So the distinction is that you won't have a widespread of the problem. So the nematodes won't be swimming around the soil so much to infect other plants, but you can still have infection take place. The other point I wanted to make is that when a plant is stressed, it tends to be more vulnerable, it tends to be more susceptible to diseases. Sometimes you have the excessive exudates or produced by roots when they're under stress, and that tends also to promote infection. So the point being made here that although the juveniles require free moisture in the soil to swim and infect roots, you also have some infection that will be limited, but it can still be there. So we simply can't ignore the problem of soil-borne pathogens. So one thing that we have been mentioning with regards to managing SCN is the use of resistance, and I'll talk more about it. But the challenge has been that the resistance we've been having is from one source. It's called PI 88788. And because of that, we have SCN populations that have developed resistance. And so because of that, we have a coalition now at the national level where we're promoting the awareness of this SCN resistance and the need to switch between varieties. And so if you have not heard about the SCN coalition, there's a website here that you can get more information as far as what it means to test your soil and knowing your number, which is the number of nematodes that you can find in your soil, because that should influence the different management practices you're going to use. So when it comes to SCN sampling, we recommend that periodically you take a soil sample of your field, whether you found SCN in the past or you haven't done it, or you haven't found SCN in the number of times you've tested. It's important to do this periodically, probably after 3 years. One is to keep an eye on the SCN population in the soil. So if the population is going up, that means you need to change the management practices we're using. If it is resistance, so switch between sources of resistance. If it is nematicide seed treatment, probably switch and use a different nematicide. But sampling is going to be really crucial so you know exactly what's going on. In the few years past, we have had a lot of flooding where we've had a lot of soil movement. And so if your field has been negative in a few years back, it could be that now SCN has moved in. So testing your soil periodically is going to be important. Of course, this is free of charge. If you bring your sample to SDSU plant diagnostic clinic because of the grant from the Soybean Research Council. So if you're taking a sample, we recommend about 20 soil cores zigzag around the field. At least make sure you get some areas in the field sampled, including low spot areas or where you have high pH, because research has shown that SCN can be you can have high populations where soil pH is high. Where you have low yield and long field entrance areas, those are likely areas where you will see high SCN populations. So when you're picking your soil, make sure those areas are represented. And this is the address of the SDSU diagnostic clinic where you can send the soil samples or drop them off. Again, SCN test is free of charge, so we encourage you to test your soils and know the status of SCN, and that can guide on your SCN management. So talking about SCN management, I already mentioned source of resistance. So PI 8788 as a source of resistance is still effective. However, we see some populations that can overcome this resistance up to about 25%. So, theoretically, you still have 75% control, but as I have some data to share, even with resistance, you still have some SCN reproducing on the variety. We have some other sources of SCN management. So if you have been using PI 88788, you can switch and use picking. A few of those resistant varieties are coming on market. We need to rotate sources of resistance, again, in order to avoid adaptation of SCN populations on our lines. When it comes to SCN management using nematicides, we have a few products on the market. The Phytophthora, which is Saltro, just came on market recently. Ilevo has been around. We have Clariva, which has also been around. Avio is a new product, relatively new product from Varenhorst. So these are some options you can use when it comes to nematicide seed treatments. However, I'll make a distinction that nematicide seed treatments tend to be more where you may get a yield response if you're starting with a high SCN population. So if your spring SCN testing is giving you, above 6,000 eggs per 100 cc of soil, then a nematicide seed treatment would be recommended. But where the population is low, using a resistant variety and rotations would help keep that population low. So here I have some data of the trial we conducted in 2019, looking at a susceptible variety treated with either Clariva or Ilevo, and also a resistant variety here with the same treatments. So the distinction here that I wanted to make is that the number of SCN at the end of the study, so this would have been in the fall, when we sampled in the fall, you can see that there were very few SCN that reproduced on the resistant variety compared to the susceptible, even with some seed treatments. So a susceptible variety is not the way to go when managing SCN. Of course, the question is, if you don't do the tests and you don't know that you have SCN, you may be just breeding, you may be increasing the population of SCN in your field, whereas a resistant variety is going to keep that population in check. As you can see here, at the end of the season, you still have low numbers. By the way, this field had very high SCN in the previous years, but now when we did the sampling in the spring, we didn't see a high population, but this could be just field variation. So really the resistant variety is the way to go when handling SCN. Again, if you have high SCN at the start of the season, I may want to consider a nematicide seed treatment. This is irrespective of the conditions at planting, whether dry or wet. For SCN, we can still see SCN build up throughout the season. So a good start with a nematicide seed treatment, especially where the initial population is high, would be recommended. The other thing we need to remind you is about weeds that are also hosts for the soybean cyst nematode. So here we have pennycress. This is a common annual winter weed that we see in fields around South Dakota. The problem is that if you don't control this weed proactively, the other management practices that you're using to control SCN may not be as effective, because now SCN will continue to reproduce on these weeds. So if you do crop rotation, but then you control weeds quite late, you could have the nematode continue to reproduce on this weed. Or here, an example where you have corn, it's good to rotate away from soybean. But again, if you have these weeds continuing to be in the field, then SCN will continue to reproduce on these weeds. So weeds need to be managed proactively. So now, because of time, we're going to rush through another disease that can infect soybean throughout the season. This is Phytophthora root rot, and as you can see here in this field, this is, here I have two examples where, the soybean was much after the seedling stage, but you have plants that are killed by Phytophthora. So I did mention something about Phytophthora being an oomycete, and it can be encouraged by compacted soils or low spot areas where you have poor drainage or where you have heavy clay soils. Again, this is a function of moisture movement. Compacted areas means that, if we have some moisture around the root zone that is free, and it's staying in those areas near the root, then you have Phytophthora infecting the plant. Low spot areas, of course, would be where you have poor drainage, the same with heavy clay soils. So the challenge with Phytophthora management is that you have so many races. And so here I'm showing an example of some of the races we've tested in the greenhouse here in the lab. And what we have seen is that varieties that have these resistance genes with one are likely to be defeated by several isolates that we find in South Dakota. So the same with RPS gene 7, excuse me, is also frequently defeated by several isolates we find in South Dakota. So that's a challenge of Phytophthora. And so if we're thinking of using resistance, we may want to pick varieties that have resistance genes in this area. So that would be 2, 3A, 3C, 6, and 8. So RPS 8 is pretty resistant to several isolates of Phytophthora. So for managing Phytophthora, we want to be thinking about the resistance genes that are going to be more durable and not the ones. So 1A, 1C, 1D, 1K, probably not 1D, but 1K, 1C, 1B, and 1A. Those are likely to be defeated, so you don't want to be using those varieties with such genes for RPS, for Phytophthora management. Excuse me. So when it comes to seed treatments for managing Phytophthora root rot, we have a few active ingredients. There's a relatively new active ingredient, oxanthiopiperorin. that is pretty good against Phytophthora. Again, if you're looking at seed, using seed treatments, look at the risk factors. Although we're a bit dry now, but Phytophthora can infect the plant throughout the season, even after the seedling has emerged. Whereas other pathogens like Pythium, like rhizoc, the risk of infection goes down as the seedling matures, as more days pass after the seed has emerged. So again, looking at seed treatments, these are not for every field, as Adam mentioned in his presentation. Depends on the field conditions, depends on the field history, depends on the time of planting. If you're planting area where temperatures are cooler, so less than 60 degrees Fahrenheit, the risk goes high for these pathogens to infect the plants. So look at these risk factors as you consider applying a seed treatment. Excuse me. Then you also want to look at other management practices, especially host resistance where it is available. That would be a cheaper way actually and effective way of controlling some of these problems. If you're looking at the ingredient to use for Pythium and Phytophthora, we have specific ingredients of metalaxyl, mefenoxam, ethaboxam, and then the new active ingredient would be what you need to use for those water mold pathogens. And then also the application rate. Make sure that what is put on the seed is going to be sufficient for controlling those diseases. Then as a reminder for these pathogens, if you have a poor quality of the seed, using seed treatments is not going to compensate for that. So you need to make sure you have a certified healthy seed that you're planting. Even when you put a seed treatment, that will be a complete protection than to use seed treatment on poor quality seed. And then seed treatments are not going to last the entire season, so don't rely on seed treatments to manage some of these problems. As I mentioned, Phytophthora, soybean cyst nematode, those pathogens can infect the seedling anytime throughout the season. So you want to make sure that you are including other management practices and you're not relying only on seed treatments. And then seed treatments are not going to control all pathogens. So some of the problems we have, as I mentioned, from Fusarium to Pythium to nematodes like soybean cyst nematode, depending on the active ingredient you're using. So not every seed treatment or fungicide or nematicide will control all the problems we find in these seedlings. So with that, I'm going to stop there, and I don't know if Connie has time to make a comment on the tests that we have available in the lab for you during the season. But this is my contact information. If there are any questions throughout the season, I'll be happy to come down and look at your field, pick samples, and test and help you diagnose and provide management recommendation for different problems you may have on your field. So with that, I'll hand back to you, Connie.
Thank you, Emmanuel. Yes, he is completely right. The cheapest investment you can make out there is to get whatever's happening in the field accurately diagnosed. You could save a ton of money off of fungicide and whatnot if you get the proper diagnosis of what's occurring out in the field. But we want to thank you for sticking with us for today's drought hour. Emmanuel does have a question in the Q&A. Emmanuel, is field history more important than soil and environment conditions for the potential for root rot issues?
Right, so field history is pretty important. As I mentioned, if you've had Phytophthora in the past, you're likely to have it again. Although the initial conditions at the time of planting are also very important, but like I mentioned, some of these pathogens that stay in the soil for a long time are going to still be there, even when at the planting time things look better. So I would say that whereas you can't rank risk factors as to which one is the most risk factor, but I mean, you should consider all these things in a sum or in lump sum to make that decision whether seed treatment is the best choice for you to make. So yeah, of course, field history is really important. I mean, if you have a very well drained soil, for example, and you've never had Phytophthora, then there would be no point in applying that treatment for Phytophthora if the risk for it is you have not seen it in the field.
Thank you. I'll have Matt go ahead and launch the poll. We have a brief 2 questions that we would appreciate those that are in attendance to answer, to kind of give us an idea of what you thought of the presentation and what we can do kind of going forward. For those of you that are still on the line, just wanted to let you know that with the diagnostic clinic, if you send in those soil samples to the diagnostic clinic, it is free for South Dakota soybean growers, that we can test the diagnostic clinic can test for nematodes and kind of give you a reading on that. They can also do some HG testing and do some different testing for Phytophthora. So again, please utilize the diagnostic clinic. Kind of wait a moment or two here for the last few to answer the 2 questions, and then I will show the QR code for those of you that are a CCA or a certified crop advisor. So if you want to start getting your mobile device handy and get that app open so you can scan that QR code for those credits. We do have another drought hour next Monday at 11 a.m. Central. We'll have a presentation that includes focus on the numbers for your drought plan by Jack Davis, and then a climate update with Laura Edwards. But thank you for those that answered that poll. I'm going to go ahead and share that QR code, but if you still have additional questions for any of our presenters today, please go ahead and drop them into the chat or into that QA feature. So far, I'm not seeing any questions in the chat or the Q&A, but would just like to thank you for attending today's drought hour, and we look forward to another webinar series, not necessarily a drought, but another webinar series next week. And so with that, I just want to thank you for attending today's drought hour, and hopefully we can get some of you to tune back in next week.